Here I'll discuss another special case of multiple cash flows. This one is called an annuity, and it refers to a series of constant and evenly spaced cash flows that occur for a fixed period of time. Now I assume you already watched the videos on multiple cash flows and the perpetuity. If you haven't, please go back and look at those first because this one builds off of them. Okay, so once again, let's first review the general rule for present value. To find the present value of a series of cash flows, you want to find the present values of each individual cash flows and then sum them up. That's what this formula does. You calculate the individual present values one at a time, and then you add them together. This is always going to be true for multiple cash flows. So what I'm showing you here is just another special case. All right, here's the example. And this example looks a lot like what we looked at in the perpetuity, with one exception. We've got this annual graduation party, but instead of the party occurring every year forever, it's only going to occur 8 times. It's going to occur in each of the next 8 years, with the first party occurring 1 year from today. This, by definition, is an annuity. As before, we're trying to figure out how much must be donated today to fund this series of parties. In other words, we're trying to find a present value. Of course, we can use the general formula in a timeline to do this as before, and so we'll start with that framework. So here's the timeline. So note that in contrast to the perpetuity, this timeline ends 8 years from now. Okay, from here we could go straight to our basic present value of a series of cash flows formula and do the calculations. We'll do that first. Go into this equation and insert the relevant numbers. And so there'll be 8 of these terms total. And then we could run the numbers through a calculator, and we'll see that this present value is $64,632.13. And so we would say that we are indifferent between $64,632.13 today and this series of 8 $10,000 evenly spaced cash flows over the next 8 years. $64,632.13 is the present value of this annuity. Okay, so this is always doable, right? But given the number of terms, it is tedious. Fortunately, there is a simpler way. So once again, we need to make sure we're clear on some definitions for this special case. First, the annuity, as I've already said, it's a stream of level cash flows over a finite number of periods. And so the level cash flows means all the cash flows are the same, and we will call the cash flow amount C. And the first cash flow must occur in period 1, and it does, of course, in the example that we were looking at. And then finally, the cash flows only occur over a finite number of periods. And so we'll say the letter cap T is the total number of periods for the cash flows. And so in our example, C is 10,000 and T is 8. All right, so with this in mind, Here is a simplified version of a standard present value formula. Note two things. One, there are no subscripts on the C's, so all the cash flows are the same. And second, note that there are a finite number of terms in this series, and it ends at time t. Now, as with the case of the perpetuity, some additional mathematical properties allow us to simplify further. So the simplified version of this equation is here. Now, a little bit more complex than what we saw with the perpetuity, but still it's a very workable thing. A couple of components. First, this C, you might refer to this as the annuity payment. And then the second component is this big term in brackets, and one might refer to that as the annuity factor. So what's the present value of an annuity? It's the annuity payment times the annuity factor. Now, going back to our example, we can find the present value by inserting the annuity payment for C and then the discount rate and cap T to build the annuity factor. You can solve that with your calculator, but you'll get 64, 6, 3, 2, 13, just like we did before. Now, I'll go ahead and mention that this formula right here is a little bit tedious to input in the calculator. Fortunately, a standard financial calculator actually has some functionality that will do this for you, and we'll talk about that at a later time.